Okay, this starts chapter 6, the counting chapter that we have, and we're going to look at the fundamental counting principle first. So this is, if you look at the background, this is on page 184, and the counting principle is in a nice little box there on page 185 of your textbook. And it basically tells you that if you have a series of events where you have a certain way of making a decision for each event, you just multiply the number of decisions you have by the number of possible decisions in each case together to get the total. And I'm going to illustrate that by doing examples here from, as you can see, that are laid out in front of you here. So the first one I've got, it says, how many ways can you eat breakfast if you can select from 5 different kinds of cereal? That's one element. 3 different kinds of fruit. That's the second element. 2 types of drinks. That's the third element. And a fourth element is 2 kinds of toast. So what you do is, in the counting principle, is you make 4 blanks for the 4 types of decisions you have to make. And then what you do is you put a number representing how many decisions each of those are. So that means 5 different kinds of cereal means 5 decisions to make. 3 different kinds of fruit means 3 decisions to make, as well as 2 different kinds of drinks and 2 different kinds of toast. And then you just multiply those all together to get your total number of decisions that you can have in your counting principle. So that if you multiply, that's 15 times 2 is 30, times 2 more is 60. So you have 60 ways. Okay, and let's take a look at another one. How many different 3-digit numbers can be formed from only odd digits? So we have 3-digit number, and it has to be formed from only odd digits. Well, how many odd digits are there? There's 1, 3, 5, 7, and 9. So there's 5 decisions to make here. 5 decisions, or pardon me, from odd digits only. I'm right. 5 there and 5 here. Okay, that's assuming that all the digits must be odd. Only odd digits. If I would have said if I would have said it had to be odd, these numbers could have been any number, even or odd, but I said from only odd digits, so that means that these 2 can be only odd digits as well as the rest. So there's 5 decisions each there to be made. If I were to say, so this is 125 ways. If I would have said, how many ways can you make a 3-digit odd number, that totally changes it, because then you only have 5 decisions there, but you'd have 9 decisions there and 9 decisions there. And we'll look at that a little closer as we go into restrictions a little bit. So you have to be careful how you word the question. And number 3, how many letter arrangements can be made from can be made from different letters to form a 3-letter sequence? This is supposed to be from here. Okay, so we have a 3-letter sequence, and we have to have 3 different letters. So letters of alphabet, there's 26, but we use one of them up. Or it said we could have 26. I should have put here, I forgot, with no repetition. Repeats. I wanted to show you an example with no repeats. Apologize there. So if there's no repeats, all you do is you kind of count down, because you take one of the letters away in each decision, right? Because you used one up there and you used one up there. So if you have no repeats, that's where I was going to go with this one, but I decided not to bother with it till here. So if you have no repeats, you take one of the total away because you've used it up. So if we multiply 26, 25, and 24 together, we get 15,600. Okay, continuing on. How many 4-digit numbers are multiples of 5? So this is where we start with restrictions quite a bit closely. So 4-digit numbers that are multiples of 5. So we got to look at cases, because there are 2 cases that are multiples of 5. If it ends in a 0 or if it ends in a 5. So let's look at the case where the number ends in a 5. So we got to have a 4-digit number ending in a 5. So if it ends in a 5, there's only one number we can pick there. Well, if we take the 5 out, how many numbers? We can't have a 0 here in the thousands digit, because then it wouldn't be 1,000, it would be 100. So that means there's only 9 possible numbers there, minus the 5, 8 possible numbers there. Here we have 8 possible numbers because we can have any number including the 0 there. And here we can only have 7 numbers because one of the numbers is used up there. So that's when it ends in a 5. Now what about if it ends in a 0? I'm going to do that case here. Let me just check my field of view here. Still enough space. If it ends in a 0. So I have a 4-digit number again. It must be a 0, so put the 1 there. Now the 0 is used up, so there are still 9 numbers that can go here, right? Because it's not the 5 that got used up this time. So 9 numbers can go here. Well, we used the 0 and 1 other number up, so 8 numbers can go here. We used up 2 numbers, and 7 numbers can go there. So if we multiply those two cases together, then add them, we'll get our total possibilities. So 8 times 8 times 7 times 1 is 448 possibilities ending in 5. Okay. And 9 times 8 times 7 times 1, we get 500. Let me do that again. I think I pushed the wrong button. 504 cases ending in 0. Notice there's more 0 cases because in this one we had the restriction that we couldn't put a 0 here as well. So that would be a total of, adding those together, so 8 and 4 is 12, carry your 1, you get 5, and 4 and that is 9. So you have 952 possible ways. So we have to be careful when you're dealing with restrictions. This one here had no restrictions. This one here had no restrictions. This one here I added in no repeats, so there was a restriction that you had to take 1 out. Here I added in that you had to have a multiple of 5, so you had 2 cases that were multiples of 5, so you had to do each case so that you could figure out and then add them up. And we're going to flip over here. I think I've got a couple more here that have restrictions on it, and I think I've got enough to... How many 5-digit odd numbers can be formed larger than 50,000 but less than 80,000 without repeating digits? Okay, so that's our next restriction one here. So what we have to do is we have to do cases in this case. So 5-digit odd numbers. Let me stop here for a sec. I think I'll continue this in the next one. I'm running out of a bit of time here.